Welcome. This is Coach Dorf, and we're in section 2.7, and we're looking at an example like a homework problem. In this problem, it says find the slope of the tangent to the curve f of x equals 1 over x squared at x equals a. Now, the formula for this is to do that the slope m is equal to the limit as h goes to 0 of f of a plus a minus f of a all over h. Now, before we go further on this problem, I want to point out something. This problem says find the slope of the tangent line. This also works if we have the other types of problems. So this also works for the fact if we have a problem that says find velocity, because then velocity can be written as the same thing, the limit as h goes to 0 of f of a plus h minus f of a all over h. And it also works if we're trying to say, if we find f prime of a, because f prime of a equals the limit as h goes to 0 of a plus h minus f of a over h. So in other words, anytime you see a homework problem in this section that says find the slope of the tangent line to the curve, or says find the velocity, or says find f prime of a, you're going to use this same approach. All right, so what do? Well, we know our function f of x is 1 over x squared, and we're looking at it at x equals a. We're going to use this formula up here above. I'm going to circle in purple. All right. So the slope is going to equal the limit as h goes to 0 of f of a plus h minus f of a over h. And I can rewrite that then as the limit as h goes to 0. And now I'm going to plug in the value of f here. So f is 1 over x squared. So f of a plus h would be 1 over a plus h quantity squared. And what is f of a? Well, I put a in for x and I get 1 over a squared. And then in the denominator, I have my h. All right, now, if I evaluate a limit, I can substitute in h equaling 0. And when I do that, I get in the top, I get 1 over a squared minus 1 over a squared, which is 0. And in the denominator, I get 0. So you have 0 over 0. So you have to use a technique to solve this, to simplify this. And this is something we did earlier in evaluating limits. In this case, what I need to do is get a common denominator for the terms in the numerator and then simplify them. All right, so I write this, the limit as h goes to 0. What's my common denominator? Well, it's going to be a plus h quantity squared times a squared. So I'm going to have that in terms of both parts in the numerator. My denominator stays the same. Now, in order to make this in blue have that common denominator, I have to multiply the denominator and the numerator by a squared. So I'm going to have 1 times a squared, or a squared, in the numerator. Likewise, here in green, this 1 over a squared, if I have that get the denominator h quantity squared times a squared, I need to multiply the original one in green by a plus h squared in the top and the bottom, and that's going to give me then a plus h quantity squared on the top. All right, so now we're going to do some combinations. So in the numerator, I have the same terms, so I can rewrite that as just having one denominator. And so I'm going to have a squared minus parentheses a plus h quantity squared all over a plus h squared times a squared, and that's all over 8. So I've added those two fractions together who have a common denominator. I've added those two in the numerator together. Now, what about this h in the bottom? Well, really what we have is a fraction over a fraction. All right. And now you may say, well, in the bottom, we only have that h, and that's not a fraction. Well, I could put a 1 down there, and now it looks like a fraction. And when I am dividing fractions by another fraction, it's equivalent to multiplying by the reciprocal of the denominator. So I'm going to write the top part of this fraction. So here's my big fraction bar. What's on the top? I have a squared times parentheses a plus h quantity squared over a plus h squared a squared. And now I'm going to divide by the reciprocal of the denominator. So that means I'm going to multiply by the reciprocal of the denominator. So I'm going to multiply by 1 over h. And then what I want to do is simplify what's on in the numerator of the first part of that fraction there. I want to simplify that a squared minus parentheses a plus h quantity squared. So I have the limit as h goes to 0 of a squared minus a plus h quantity squared is going to be a plus h times a plus h, which is a squared plus 2aa plus h squared. And that's still over the same denominator. And now, because I'm multiplying that all by 1 over h, I can bring the a under into the denominator of the one term. And so I just have one fraction there. All right. And then from here, be careful. What I need to do is I need to distribute this negative sign in front of this parentheses to all three terms that follow after it. This one kind of goes through there. All right, so when I do that, I have a squared minus a squared. So that's this part. And then I have a minus 2ah. That's this part. And then I have a minus h squared, which is the last part right there. And then in the denominator, I have a plus h quantity squared, a squared h. Denominator hasn't changed yet. All right, so then I look at this and I say, what can I cancel out? And in the numerator, I can cancel out an a squared, so that you end up with a limit as h goes to 0 of negative 2ah minus h squared over a plus h quantity squared, a squared h. Now, because the limit is of h going to 0, I should be able to get an h on the top and an h in the bottom that I can cancel out. Now, in the denominator or the bottom, I already have my h, right? I have that right here. All right, but I don't have an h in the numerator that's multiplied by everything. So let's go ahead and factor out an h in the top. And when I do that, I'm left factor out an h from the negative 2ah. I'm left with negative 2a. And I factor out an h from the negative h squared, and I'm left with a negative h. All right. Now I have an h in the bottom, in the numerator, and in the denominator. So in the numerator, I can cancel that out with the h that's in the denominator. And so I'm left with this, negative 2a minus h over a plus h quantity squared, a squared. Now that's a really important step, the one that we did in red here, where we crossed out the h, because that's where, when at the very beginning of the problem, I plugged in or substituted in h equals 0, and we got 0 over 0. The fact that now we canceled out the h's, an h in the top and h in the bottom, allows us now to reevaluate this, and we see that we don't get 0 over 0 anymore, right? If I take my limit here and now substitute in h equals 0, in the numerator, I get negative 2a minus h, but h is 0, so that's 0, over a plus h, but h is 0, so it's just going to be a plus 0 squared, or a squared, times a squared. All right, so then I get negative 2a over a to the fourth, and I can simplify the a's there by reducing an a in the top and the bottom, and I get negative 2 over a cubed. And that is my answer. Again, remember that in this type of problem, all right, we were trying to find the slope of the tangent line. And we did. At the slope of this tangent line to the curve f of x equals 1 over x squared at x equals a. We found that. All right, it was negative 2 over a cubed. But this also works if the problem had said find the velocity of the function f of x equals 1 over x squared at x equals a. And this also would have worked if we just said, if the problem said find f prime of a if f of x equals 1 over x squared at x equals a. All right, hope this helps.